What if I told you that right now, artificial intelligence isn't just creating virtual worlds, but actually dreaming them into existence? While you were sleeping last night, AI systems across the globe were generating entire universes, complete with physics that defy reality, landscapes that morph based on your emotions, and characters that learn and evolve in real time. And we're not talking about the clunky VR headsets gathering dust in your closet. We're witnessing the birth of something far more profound. Machines that don't just render virtual reality, they imagine it. Welcome back to the channel where we dive deep into the technologies reshaping our digital future. I'm your host, and today we're exploring one of the most mind-bending intersections of modern technology, AI-driven virtual reality design. By the end of this video, you'll understand how artificial intelligence is revolutionizing the way virtual worlds are created, why this matters for your future, and what it means when machines start dreaming in pixels. But first, let me paint you a picture of where we're headed. Imagine slipping on a VR headset and entering a world that not only responds to your actions, but also anticipates your thoughts. A virtual environment that reads your stress levels and automatically adjusts the lighting to calm you down. NPCs that remember every conversation you've ever had with them and reference those memories months later. Landscapes that shift and evolve based on collective user behavior, creating stories that no human designer ever explicitly programmed. This isn't science fiction anymore. It's happening right now, and the implications are staggering. Traditional virtual reality development has always been a massive undertaking. Teams of artists spend months crafting every texture, every building, every blade of grass. Programmers write thousands of lines of code to dictate how objects behave. Sound designers layer audio tracks to create an immersive atmosphere. It's a beautiful process, but it's also incredibly time-consuming and expensive. Most importantly, it's limited by human imagination and resources. Enter artificial intelligence, and suddenly we're playing by entirely different rules. AI-driven virtual reality design represents a fundamental shift from human-created static worlds to machine-generated dynamic universes. Instead of developers manually placing every tree in a forest, AI algorithms can generate entire ecosystems that follow realistic biological patterns. Rather than animators keyframing every character movement, machine learning models can create natural, responsive behaviors that adapt to player interactions in real time. The technology stack behind this revolution is fascinating. At its core, we're looking at several key AI technologies working in harmony. Generative adversarial networks, or GANs, are creating visual assets that rival human artistry. These systems pit two neural networks against each other. One generates content while the other evaluates its quality. Through this competitive process, GANs can produce textures, models, and even entire scenes that are virtually indistinguishable from those created by humans. But GANs are just the beginning. Procedural generation algorithms powered by machine learning are creating vast, explorable worlds that would take human teams decades to build manually. These systems don't simply scatter objects randomly around a landscape. They understand environmental relationships, architectural principles, and aesthetic harmonies. They know that certain types of vegetation grow near water sources, that settlements develop along trade routes, and that lighting affects mood and navigation. Perhaps even more impressive is how AI is handling the behavioral aspects of virtual worlds. Reinforcement learning algorithms are creating non-player characters that genuinely learn from their interactions with players. These aren't scripted responses following predetermined dialogue trees. These are entities that develop personalities, preferences, and memories through their experiences in the virtual world. One of the most exciting developments is the emergence of what researchers refer to as adaptive world generation. Traditional virtual worlds are static. Once a game ships, the environment remains essentially unchanged. AI-driven systems can continuously modify virtual spaces based on collective player behavior, seasonal real-world events, or even trending topics in social media. Imagine a virtual city that develops new districts based on where players congregate most frequently, or weather patterns that reflect the mood of the global player base. The creative implications are profound. AI isn't replacing human creativity, it's amplifying it exponentially. A single artist can now collaborate with AI systems to generate hundreds of variations on a concept, exploring creative possibilities that would be impossible to pursue manually. Designers can describe their vision in natural language, and AI can translate those descriptions into fully realized 3D environments. However, this collaboration extends beyond simple asset generation. AI systems are beginning to understand narrative structure, emotional pacing, and player psychology. They can analyze how players move through virtual spaces and automatically adjust level design to maintain optimal engagement. They can detect when a player is becoming frustrated and subtly modify challenges to maintain the perfect difficulty curve. The technical challenges of implementing these systems are immense. Real-time AI processing requires enormous computational power. Current VR headsets struggle with the processing demands of traditional rendering, let alone the additional overhead of running complex AI algorithms. Cloud computing offers a partial solution, but it introduces latency issues that can break the immersive experience that makes VR compelling. Memory management becomes crucial when dealing with AI systems that require tracking vast amounts of player interaction data. Every conversation with an AI character, every environmental modification, and every behavioral adaptation needs to be stored and accessed instantly. We're talking about databases that continuously grow and require querying in milliseconds. The networking requirements for multiplayer AI-driven VR are equally daunting. When every element of the virtual world can potentially change in response to AI decisions, keeping all players synchronized becomes a complex orchestration challenge. Traditional networking protocols weren't designed for environments where the fundamental structure of the world can shift in real time. Despite these challenges, we're already seeing impressive implementations in the wild. Several major VR platforms are experimenting with AI-generated content systems. Some focus on creating infinite exploration experiences where players can wander through procedurally generated landscapes that never repeat. Others emphasize social interactions with AI entities that remember and evolve based on community interactions. The gaming industry is naturally the early adopter in this regard, but the applications extend far beyond entertainment. Educational VR platforms are utilizing AI to create personalized learning environments that adapt to the individual needs of each student. Medical training simulations are generating rare scenarios that would be difficult or dangerous to recreate in real life. Architectural visualization tools are enabling clients to explore AI-modified design variations in real time. One particularly intriguing development is the emergence of collaborative creation tools that enable multiple users to work with AI to build virtual spaces together. Imagine a group of friends describing their dream vacation destination, and AI instantly generating that environment for them to explore together. The social implications of shared AI-assisted creativity are only beginning to be understood. The psychological impact of AI-driven virtual worlds deserves serious consideration. When virtual environments can read and respond to our emotional states, the line between reality and simulation becomes increasingly blurred. These systems can potentially influence our moods, behaviors, and decision-making in ways we don't fully comprehend yet. There's also the question of ownership and authorship in AI-generated virtual worlds. When an AI system creates a beautiful virtual sunset or designs an engaging puzzle, who deserves credit for that creation? The programmers who wrote the AI, the artists who trained it, which players whose behavior data influence the generation process? These questions will only become more complex as technology continues to evolve. Privacy concerns are equally significant. AI systems that can read our biometric data, track our eye movements, and analyze our behavior patterns in virtual environments have access to incredibly intimate information about who we are as people. The potential for misuse of this data is enormous, and we're still developing the regulatory frameworks to protect users. Looking toward the future, the possibilities become even more exciting and concerning in equal measure. We're approaching a point where AI could generate entire virtual universes on demand, complete with their own physics, history, and inhabitants. These wouldn't just be game worlds, they could be fully realized alternate realities with their own cultures, economies, and social structures. The convergence of AI-driven VR with other emerging technologies promises to create experiences we can barely imagine today. Brain-computer interfaces could allow AI to read our thoughts directly and generate virtual environments that respond to our subconscious desires. Quantum computing could provide the processing power necessary for real-time simulation of complex virtual ecosystems. Advanced haptic feedback could make virtual objects feel completely real to our sense of touch. We might see the emergence of virtual worlds that exist independently of any single user or platform. AI-managed virtual societies that continue to evolve and develop even when no humans are present. These worlds could build their own virtual economies, political systems, and cultural movements driven entirely by AI entities and their interactions with occasional human visitors. The democratization of virtual world creation is perhaps the most exciting long-term implication. As AI tools become more sophisticated and user-friendly, the barrier to creating compelling virtual experiences will continue to drop. We can envision a future where anyone can describe their ideal virtual space and have it generated instantly, resulting in an explosion of diverse, personalized virtual experiences. But this democratization also raises questions about quality control and safety. If anyone can generate virtual worlds with minimal oversight, how do we prevent the creation of harmful or exploitative environments? How do we maintain standards for user experience and safety when the tools for creation become universally accessible? The economic implications are staggering. Traditional game development studios employ hundreds of artists, programmers, and designers. If AI can handle much of this work automatically, entire industries will need to reinvent themselves. New job categories will emerge focusing on AI training, curation, and collaboration. However, the transition period could be challenging for many professionals. We're also likely to see new forms of virtual tourism emerge. Why visit a virtual recreation of Paris when AI can generate a version of Paris that never existed, but feels more beautiful and engaging than the real thing? The travel and hospitality industries will need to compete with virtual experiences that can offer impossible wonders at a fraction of the cost. The therapeutic applications of AI-driven VR are on the horizon. Virtual environments that can adapt to individual psychological needs have the potential to revolutionize mental health treatment. Imagine PTSD therapy environments that can slowly introduce triggering stimuli at precisely the right pace for each patient, or anxiety treatment spaces that can model and practice social interactions with AI entities that respond naturally to human behavior. As we stand on the brink of this AI-driven virtual reality revolution, it's clear that we're not just talking about better graphics or more realistic physics. We're discussing a fundamental shift in how we create, experience, and interact with digital worlds. These aren't just tools for entertainment, they're platforms for education, therapy, social interaction, and creative expression. The machines are indeed learning to dream in pixels, and their dreams are becoming our new realities. Whether this leads us to a utopia of infinite creative possibility or a dystopia of manipulative artificial experiences will depend mainly on how thoughtfully we develop and deploy these technologies. The future of AI-driven virtual reality isn't something that's coming someday. It's happening right now in research labs and development studios around the world. The virtual worlds of tomorrow won't just be more realistic than today's, they'll be more responsive, more intelligent, and more alive than anything we've experienced before. The question isn't whether AI will transform virtual reality design, but how quickly we'll adapt to a world where the boundary between artificial and authentic becomes increasingly meaningless. We're entering an era where machines don't just process our reality, they create new ones, one pixel at a time.